Welcome everyone. Today I'm going to discuss about one of the very important aspects of quantum computing. It's introduction and history, data representation, operations and on data, short algorithm, conclusion and open questions. What is a quantum computing? A quantum computer is a machine that performs calculation based on the law of quantum mechanism, which is the behavior of particles at the subatomic level. Introduction. I think I can say that nobody understands quantum machines. Females. 1982, Feynman poses the idea of creating machine based on the law of quantum machines instead of the law of classical physics. 1985, David Deutsch developed the quantum turning machine, showing that quantum circles are universal. 1994, Peter Shor's come up with a quantum algorithm to factor a very large number in polynomial times. 1997, Love Grover depends a quantum search algorithm with O complexity. Over introductions and history, data representations. Representations of data. Qubit. A bit of data is represented by a single atoms that is in one of two donated by 0 and 1. A single bit of this form is known as qubit. A physical implementations of the qubit could use the two energy level of an atom, an existing state representations ones and a growing state representation. Representation of data. A single qubit can be forced into a superpositive positions of the two state denoted by the additions of the state vectors, where sigma and sigma is a complex member. Representation of the data and supervisions. Considerations: a 3-bit qubit registers and quality register superpositions of all possible states would be denoted by data retrieval. In general, an a qubit register can represent the number of 0 through to n and simultaneously sound too good to be true. It is if we attempt to retrieve the value represented within a superposition, the superposition randomly collapse to represent just one of the original value. In our equations, represent the probability of the superpositions collapsing. The theta are called probability amplitudes. In a balanced superposition, theta is equal to 1 by 2, where n is the number of qubit. Relationship among data. Entanglement is the ability of the quantum system to exhibit correlations between states within a superpositions. Image two qubits as is the state 0 plus 1. We can entangle the two qubit, so the measurement of a qubit is always correlated to the measurement of the other qubit. Overview, introductions and history, data representation, operations on data, short algorithm, conclusion, and open question. Operations on the qubit. Due to the nature of the quantum physics, the destructions of the information is a gate will cause heat to be evaluated, which can destroy the superposition of the qubit. This type of the gate cannot be used. We must use quantum gate. Quantum gate. Quantum gate are similar to classical gate, but do not have a generate output. The original input state can be derived from their output step uniquely. They must be revisable. This means that deterministics computations can be performed on a quantum computing only if it's revisable. Luckily, it has been shown that any deterministic computations can be made revisable. Quantum gate, simple gate involved onto qubit and is called Hadamard's gate. A gate which operates on the two qubit is a called control not gate. If the bit on the control line is 1, invert the bit on the target line. We can build a revisable logic circuit to calculate multiplication by the two using CN gate aggregate the following manner. A gate which operate on the 3 qubit is called the control not gate. If the bit on the both of the control line is 1, then the target bit is inverted. The CCN gate has been shown to be universal revisable logic gate as it can be used as a NAND gate. Short algorithm. Short algorithm shows that a quantum computing is capable of factoring very large number is a polynomial. The algorithm is dependent on modular or arithmetic, quantum parallelisms, quantum Fourier transformism. An important result from number theory, chosen n is equal to 15x7, we got the following. Choose an integrated queue such choose a random integrated create two quantum registers. Input register must contain enough qubit to represent number as long as 1. Output register must contain enough output to represent number as large as n. Load the input register with an equally weighted supervisions of all integrated. Load the output register with all 0. Apply the transformations x and n to be each number is the input register, storing the result of each computational in the output register. Now take a measurement of the output register. This will call up the supervisions to represent just one of the result of the transformation. Let's call this value. Since two registers are intense, measured, the output register will have the effort to particularly collapse the input register into an equal superpositions of each of the state between 0 and q minus 1 that yield. We know apply the quantum frontier transformations of the partially collapsed input register. The Fourier transformer has the effect of taking a state and transforming it into a state given. Showing the algorithm, A is the set of all values. A mode 15 yields, and in one case, so the final stage of the input register after QFT is this. The QFT will essentially pick the probability amplitudes at the integral multiples of the Q by war in one case. So we no longer have an equal superpositions on state. The probability amplitudes of the above state are now higher than the other state in our registers. We increase, we measure the registers, and it will collapse with higher probability to one those who multiple 64 with our knowledge of QNP. There are methods of calculating the period. Now that we have periods, the factor of n can be determined by tackling the greatest common divisions of n with representations, and the idea that the computational will be done on a classical computing. The QFT comes off short and reveal the wrong period. This probably is actual dependence on your choice. The larger the Q, the higher the probability of finding the correct probability. The period of series ends up being odds. A 7-bit machines were built and programmed to run Shor's algorithm to successfully factor 15. What algorithm will be discovered next? Can quantum computing solve any complete problem is polynomial times? So these are the very, very important discussions of the quantum computing, and this, through the quantum computing process, we can develop the new technology, and this technology can help us to grow our economy in a sustainable way. If you have any question, you directly can communicate with me. Thank you, bye-bye, and take care.